going through it
No worries.
yesterday because I had to move.
Gotcha. How'd that go?
Good. Well, I like half moved. Mostly we just moved my fiance into the new place. I like
Gotcha.
moved all most of my stuff over there, but I still stayed the night at my old place.
Gotcha. When do you guys get married?
November 18th.
Oh, like 2 weeks, 2.5 weeks.
Yeah.
Well, sweet. Alrighty. Ready to get started?
Yeah, but we don't. You have class at what time?
11:30. So I'm good till about 11:05, 11:10.
Okay. Well, if it's anyway, we don't have to go through the whole thing. We can
Gotcha.
we can go through like what we know for sure, and then talk about some of the questions.
Gotcha. Yeah, so I went through the whole thing, and anything that I felt like I didn't know, I just left blank. So,
Yeah.
so
Okay.
we'll see. But yeah, it shouldn't be too bad.
Okay. Sounds good. I cannot find my calculator anywhere, so it's
No worries.
in this place in the move. So I'll just have to use my computer. Okay, number 2.
Yes. So for number,
Oh, go ahead.
I just put 90% confident that the true mean heart rate is between 45 and 105.
Yes.
Is that what you put?
Yeah.
Okay. Cool.
Number 3, I put yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yeah, I wasn't sure. Cause that was one I had a question on. Because I wasn't sure if there was enough to be considered like a large enough sample.
Yeah, I wondered that too, but it
That,
doesn't. Yeah, but it doesn't say anything about that. Oh wait. Oh, right there. Okay.
yeah, that was the first one said not a large enough sample. So I was in between that one or it's normal since it's been determined to be normal.
Okay.
But yeah, I'll go with the yeah.
Okay.
Yes.
So
And
the
then
only, I mean, I don't know where. Hold on 1 second. I don't know where. I can't remember which chapter it was that went over that. Anyway, because we could just check if it matters the size or not.
yeah. I know that's because cumulative there's like 14 different lessons to cover and I was like,
Oh, I forgot about that. But definitely the last exam will also be on this.
yeah. Yeah, I guess it'll answer our question if it's not yes.
Yeah.
Then with 4, I put, at least my thoughts were that the confidence interval for the difference of means using using independent samples. But I'm not positive. Because I feel like the questions, the 20 females and 15 males, because they're random, it would be they'd be independently sampled.
Yeah, I think they would be too. I think I would agree with that.
Alrighty, cool. And because we have no idea what the standard deviation is for either, it doesn't give us any information on it.
So if that's wrong, then I would say it's option number 2.
When it's unknown.
Yeah. Okay, number 5. I put compute and this one I didn't really know, but I put computer 99 confidence interval rather than 95.
Yeah, I put the same.
Okay.
Because it said a smaller margin of error, which would mean
95 or 99 is smaller room for error than.
yeah. Because if you take what 99% of people will be in, there would be less error than for 95 because it always gets smaller.
Yeah.
Sweet. And then for 6, I got 998.355 and then 1001.645.
Question: where did you input these?
On
Like, is on the quantitative thing?
what I did is I used the margin of error equation.
Okay.
Yeah, which for the 95% would be 1.96 times, and then so YS standard deviation divided by the square root of the number times 1.96.
Okay.
But yeah, but since there was no number given, it's just believe it's just standard deviation times the confidence interval number. So just 1.96 times 2, which ends up being.
Okay.
Then you take 1,000 minus those two. Or wait a minute, I lied. I forgot. So I got B 996.08. That's what it was.
Wait.
99. So do you have the lesson 15 review up as well?
Not see the margin of error though? That big of number? I don't really know.
So because it's saying calculate the 95% confidence interval.
Uh-huh.
And so if you take 2 times 1.96, it's like
Yeah.
3.92.
Uh-huh.
Yeah, and so you would just add and subtract that from 1,000.
Oh, okay. So those
That
are
makes
the upper
sense.
and lower bounds. So 3.92 is the margin of error.
Yeah.
Okay, I thought you were talking
3.92.
about those numbers for the. I guess it could be. Never mind. I don't know what I was thinking. Okay.
Yeah. Those are the margin of error. Then the other two are the confidence intervals
Okay.
that I was talking about. All right. Then 7 and put. Oh, okay. I was answering the next two questions already. My bad.
So those need to be rounded to 3 decimal places.
Yeah. So it'd be
So just put a
996 point. Yeah, I just put a 0 at the end of both of them.
Does number 6 need to be round to 3 as well?
Generally, I would assume so because it usually says at the top to round to 3. Yeah, round to 3
Okay.
unless told otherwise.
Sorry, I didn't know my thing was there.
No worries. And for this one, I got 3,000 or 38,416. But that's only, well, it's right because I just plugged it in and put in put that in as the number until I got the margin of error. But
Oh, this one I don't. That's one thing I need to go back and look at. I don't know how to do those ones.
Gotcha. Yeah, because for this one, what you would do to find the answer is you would set it up as 0.001 is equal to 1.96 times 0.01 over square root of n. And you would basically bring the square root of n to the other side.
And it was what equals that? Oh, the 0.0001.
Yeah.
Okay.
And so what you would end up doing is 1.96 times 0.01 all over 0.0001. And once you found that answer, you would just square it.
Okay.
To cancel out the square root on the other side.
Yeah.
And then you'd come up with the answer.
Okay, I see. So let me do that math real quick.
Yeah, go for that. I'm going to go grab my calculator while you're doing that. All right. Did it come out to be right?
Hold on, I haven't done it yet.
Oh, sorry.
You're good. So, sorry, wait a sec. You said it's 1.96, because that's the 95% times 0.01, and is it both of those over n, over square root of n?
No, so those are here, I'll write the equation relatively big so you can see it. All right. So, you see that pretty well?
Yes. Hold it there for just a sec. Oh, I need to stop talking. You say it again, because it switches screens when I talk.
Oh, okay. So,
Okay. I think
does that make sense how you end up with that?
Uh-huh.
Yeah, you got to get square root of n to the other side, and then you just got to square it to get rid of the... Yeah, then you square the whole thing because you have to square both sides.
Yeah.
Which puts you at 3,800 or 38,416. I guess we would put 0.000. I don't know.
Wait, you got, what was your answer?
38,416.
Yes, that's what I got as well.
Gotcha. I just put 0.000 at the end because the way that it reads it, I just never know if it's going to be like, well, you didn't put it to a third decimal, so it's wrong.
No.
Alrighty.
Okay.
But that makes sense to you now?
Yeah, that makes a lot more sense.
Okay, cool. Then the next one.
Number 10, I put the last option.
Let me see what I've... Yeah, I put the last option as well. Then 11. I put the
You got
p-value less than alpha.
Okay. 12.
12, I wasn't 100% sure on.
I put the third option, but let me reread it. I guess it's kind of the same question as that other one. Just to know, we need to know if they're, because I mean, it would be enough if the sample variance, because everything fits. It just is if there's enough.
Yeah, because 30, right? That's the, or which one's 30? Is that central theorem? And so you put, yes, it's enough. Has a bell shape, no outliers, and sample variances.
Yeah.
And then if that's not right,
then I would say no, they don't have enough data.
Okay.
Because the reason that we're saying that one is right is because we believe that they are in central limit theorem, but that wouldn't be the answer.
Gotcha. Oh, central limit is 60, and so there's no way it could be.
No, central limit theorem is 30.
Is it 30? Oh, which makes sense. So the last one, there's no way it could be right because the whole 60 GPAs.
Well, it is. I mean, technically, it's kind of right, but
there's other stuff that has to go in. Like the variances have to be equal.
Yeah, yeah. I mean, and that is right because the third answer, that's the actual requirement for the ANOVA test.
Yeah. Yeah.
Yeah. Okay, so 12. Yes.
Gotcha.
Okay, 13. Oh, this one I wasn't sure. I kind of played between two.
Either type 1 or
yeah.
Or type 2.
Well, no, I know that it would be a type 1 if it's that, but I didn't know if it was that or if it was an incorrectly used significance level.
See, I put type 1.
Okay.
It was 0.05 significance. Yeah, I don't think, like, they just, because significance level, we don't really have any way to determine why it would or wouldn't be the specific significance level.
Okay. If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? It would increase, wouldn't it?
Yeah, see, I either put it was either the first answer or the third answer. But I assumed that it would increase it because the type 2 error was that you said you wouldn't reject the null, but you end up rejecting it.
Yeah.
And so, yeah, it makes it difficult because I try to think through it and I was like, I don't know what it would do.
Because if you have that whole span and you decrease, so it's kind of like if you have like this is your bell curve, and from this interval to this interval is like the probability of committing one error. On this interval is another. If you decrease that, then it increases the other. Like that's how I'm thinking it in my head. I don't know if that's true.
Yeah, that makes sense because that's also probably because if you give a 0.01, my guess is I would probably say, well, that's a less, like in my mind, I sit there and I think, well, it'd be a lower level of significance, so there's a better chance that I would guess that we would not reject it because there's less of a probability to do that. But at the same time, it makes it's only 20% of what 0.05 is, and so it is now, I guess, 80% less than 0.05, so it would reduce the chance that it would be a type 2 error. So I don't know. It's one or the other. But I think let's go with the increasing one. And then if it's not, then we know it's the decreasing one or reducing.
Okay. Because it would say that there is a relationship. So neither of the other options. Yeah.
Alrighty. Sweet. 15. Oh, you gotta do some math for this one, I think.
Yeah, I think we have to find the p-value.
That's right.
Back already?
Watching children play makes me want to be a child. Like, I'm like, why don't I do this? Like, why do they get to come to campus and do this and I don't?
What's the equation again for p-value?
That's what I think for p-value, you have to find the z-score and then plug it into the
probability. That's right.
But for z-score, is it x minus the hypothesis, so the sample minus the actual, and then that's over standard. So the bottom half is standard deviation divided by square root of the number, and then the top half is the sample minus actual or whatever.
Yes.
I think it is, but I'm not positive.
I think so. I don't know why. I need to put all of my equations in one place.
I feel you.
Okay, z-score, if it's... No, I think what you were doing might be t-score. Z-score is just the population mean, or sample mean minus population mean divided by standard deviation, not square root of population.
Gotcha. So the sample doesn't matter in this equation?
No, it does, but...
Or like the sample number, I should say.
No, yeah, the sample number, I mean. The population itself does not matter.
Gotcha.
I got 0.176 for
Yeah, I got the same.
6. So that is, well, we assume larger, so we fail to reject.
Yeah, that's what you get 0.4301 as the area or the p-value.
Okay.
What'd you get for the area?
I'm doing that. I need to pull up the normal probability after that.
Oh,
Is
gotcha.
Stage?
Huh?
Yeah, nothing.
Oh.
I was just.
Yeah, what I ended up doing is I just took the normal probability and the t-score probability thing, and I just bookmarked them.
I need to do that.
Yeah, because it just makes it a whole lot easier, and I don't have to worry if it's going to be like given to us.
Yeah. Okay, so you want which end highlighted? The left or
The
right?
right side.
Okay.
So we're saying it's greater than 1.5, so we'd say
I got 0.4301.
Okay, I got the same. So
that is, yeah, so we failed to reject. Correct. Okay, 16. You'd like to. Would that be a paired sample t-test? Or an independent sample t-test? No, it wouldn't be paired because they don't. They're independent of each other.
Yeah, so like the average number of hours worked for wages by male and female. You would like a random sample of 100 for each and test if the means are different. So it would either be. See, I put the ANOVA, but I don't think I was right. Because I know the ANOVA takes an account for like the difference of means.
Yeah.
And does the dependent or independent do that? Well, this one would be. I think this one would be independent samples because the males don't depend on the females.
Yeah.
Well, an independent, would that be considered a 2-sample t-test?
Yeah, I think, and that's what we'd want. So I think it's an independent. What do you think?
Well, my only question, because this one doesn't test if, well, yes, it does show if the means are different. It shows it, but I don't know if that's necessarily what the test is. I can't.
I think an independent samples t-test it's the same thing as a 2-sample t-test.
Yeah, I want to say it is too, because a paired sample would be the dependent because they're paired together.
No, I'm pretty sure that that's what it is.
Okay, sweet.
Okay, 17.
17.
Okay, so it would be the fourth option. Dependent sampling, because if you select the brother, then you have to choose his sister.
Yeah, I agree. That's what I put.
Okay. Okay.
For 15,
We're
15, I put, or I mean 18. It's 15 on the less than 15 review.
Oh,
Yeah, so 18, my bad. I put it was the third one.
okay.
Because the information you're given, you can know what the standard deviation is just by plugging in the numbers.
Okay. Sounds good.
But if I guess if that's not it, then I'm not sure what exactly it would be. I guess it'd be for it if it's unknown. It'd be
Yeah, my only question is because some of the time the unknowns, like it's just unknown because they didn't state it.
yeah.
Like it's known because we found it out, so it's known. But that one I'm confused on because I feel like they're not consistent with that. Well, let's just put it as known because we know that we can find it, and if that's wrong, then we would say that it's unknown.
Yeah. And yeah, that's what makes it hard. It's just like, well, it technically is known. All we have to do is highlight it and plug it in real quick.
Mm.
But yeah. All right.
Okay, determine the margin of error for this 95% confidence interval.
All right. This one, I had a difficult time with this one.
I don't know how to find margin of error.
So margin of error, you take the two confidence intervals and you add them together, and then you divide them by 2, and that's like your midpoint. And then the easiest way to do it is to take your largest interval and you subtract it, and then you take the average and subtract it from the largest, and that'll be your margin of error.
That's right. Okay, I did know that. So do we need to find the margin of error? Do we need to put this into that one spreadsheet, or do we just do the math?
I believe we have to put into this. It's easiest to put into the spreadsheet.
Okay, in the one sample t-test.
Is all. Yes.
What's the confidence level on this?
It
is 95. Thing.
Yeah, 95.
Wait, the margin of error is not on it. Wait, do you put it in a ANOVA or the... Man, my brain is dead today.
I put it in the one sample t-test.
That's what I did too. There's no margin of error on there.
So what you do? So the confidence interval.
Confidence interval. Duh, I knew that.
Yeah.
That's not correct. Okay, I got 2.0245.
Yep, that's what I got.
0.02.
Which would be 2.025.
Okay. And then the lower bound is 11.168. And the upper is 15.
Is 15.217.
Okay.
Then for 22, I put it was the third answer.
Okay. Yeah.
Because you're looking for the difference, but they're not they're not connected.
Yeah, I agree.
Then this would just be a 2-sample t-test. The question is the 95%. The true difference of mean listing price.
Wait, how come I'm only seeing one listing price?
So if you look to the very right, it'll say Los Angeles and New York, and so
Oh, okay.
yeah, I did the same thing. I was like, why is there so many for just one?
Okay. Okay, now I finally got that done. Let me go back to the question. Okay. It says Okay.
So I'm not sure. I'm assuming this is a two sample t-test, but the true difference of means, I don't necessarily know where you would find that or what that is. Yeah, I have no idea what the true difference of mean is.
I think
Oh,
you find the average of both, and then
but the numbers are just massive. The thing, cause like the mean itself is, for the first one is over 42,000, the other one's over 28,000.
wait, I got 42,641 and then 40,000 on the second one.
Oh, I wonder if I missed any. What?
Double check.
That's weird. I don't know what I did. I'm not. Oh, all right. I figured it out. I still had the leftover numbers from the last one I did, hanging out at the bottom. Okay, I have 40,000 now.
Okay.
Which
So then we would just put in the confidence interval, like the upper and the lower bound. That's
I
already
think,
right.
yeah, I think that's what it would be then. The
So
true difference, would it just be what the confidence intervals upper and lower bound is?
yeah, I don't know why they worded it that way. If that makes a difference.
Yeah, it's interesting, but we'll take it.
Okay, I got the first one. It's negative 423.238, right?
Yeah. And then
And then
5417.336.
yes.
Cool. Fifty-four 17.336. Alrighty, sweet. 25.
That one you would use an ANOVA, right?
What?
No, you'd use an independent sample test. I don't know.
See, I put ANOVA for this one.
Yeah, that's what I think. Was my initial thought.
Yeah, because there's different groups.
Yeah.
Yeah, because there's 3 groups. So because all the other ones only have 2 groups that you can use. So it's got to be. That's why I figured, because it's looking for a difference and it's got more than 2, so it's got to be ANOVA.
Okay.
And then for 26, I got 7.978.
Okay.
Then
you got what? 7.978.
Yeah, 7.978.
Okay.
The ANOVA is kind of like the easiest one because everything's just given to you. Like once you plug it in, there's no like math that you have to do. Then for 27, I got.
Hold on.
Okay, no worries.
Okay. So, number. Sorry, just one second. With the test statistic, you just.
Because the ANOVA, the test statistic is the F score.
Okay, I see. 7.98. So, 97. Okay. Okay, and then the p-value is 0.002.
Yep.
Twenty-eight.
28, I put sufficient evidence that at least one of the groups is different.
Okay.
And I put that this one was dependent samples test.
Yes.
And then I got a test statistic of 1.685.
$1.685.
Yeah.
Okay.
And then on the last one, I got sufficient evidence that there is a difference in the cost at the 14 days in comparison to the 90 days. So the third one. Well, so I just submitted real quick, and we have a 24 out of 30. So I'll go through and tell you which ones we got wrong.
Wait, on 32, did you say that there is sufficient evidence that there is a difference or that there is not a difference?
Oh, I hit not, but it should be that there is, right?
Okay.
Yeah, whoops. Well, that explains that one. And then, so the first one we missed was question 5, which
Okay.
I think this one is, it's that we should obtain the balances of 90 customers rather than 30.
Okay. That's when I was looking at that the first time, those are the two that I was playing with.
And then the next one we missed was 6. So if that's the case,
wait a second. This standard deviation is 2. So wouldn't it be 4 on this one?
oh yeah, that totally makes sense. So you do, let's see what,
95, wait, would it be 4 or would it be, yeah, I think it'd be 4.
see, but we don't have any numbers that are that large is the only issue. On the lesson review, it gives you like multiple choice options, and none of them are. So 996 or 3.92 was the largest standard deviation that we got.
No, but the standard deviation is 2. But the margin of error then would be 4.
Oh, actually, I didn't realize. So it says she randomly selects 4 drive shafts. So the number on the margin of error would be 4. So hold on, let me choose something real quick. 2. I think the standard deviation is 1.96.
For ours, for that number, it says the
Or
standard
not standard deviation. I mean a margin of error.
I think is just 1.96.
Yeah, because if you do
3.96 divided by half because
yeah, because the number is 4. So
saying.
yeah, so square root of 4 is just 2, which would be 2 divided by 2 is 1 times 1.96.
Okay. If it's not that, then I would think it's just 2. So then did we miss 7 and 8 as well?
Yes. Which would be
98 point or 998.
0.040 and then 1001.960. That would make sense. And then we missed number 15.
Okay, 1 second.
No worries.
And what was the next one that we missed?
Number 15.
Okay. Would you reject the null?
So we put fail to reject, right?
Yeah, we put fail to reject.
Which I think it's that you would reject. Because so I put it in if you take the numbers into account, like the 100 cigarettes,
Mm-hmm.
then it's 0.0388, which then puts you
Under the level.
under. Yeah.
Okay. So change that to reject. Okay.
Which. And then we missed 18. So it says that was the one where we said it was known, confidence. And so we should do unknown. And then we got the rest of them right.
Okay. I will save that and submit it. Let's see what we got that time. $29.5.
So means we missed half.
Let me find where. I wonder if I forgot to put 3 decimals. Somewhere. No. So
Which one?
number 8. I got number 7 right, but not number 8. It would be
What did you put for?
You know what? That's why I put 101.967.
Okay. So
That's
we're
why.
good then.
Yeah, so we're good.
All right. Sounds good.
Okay.
I'll let you go and good luck on the test.
Thanks. You too.
All right.
Have a good weekend.
You too. Bye.
Bye.